Hi, how you doing? My name is Sara Golemon. I work for Facebook on a project called HHVM. For those of you not in the know, that is the alternative PHP runtime. And as I say PHP, I see half of you glaze over and get disinterested. That's fine. I've also been working on the PHP language for about a dozen years or so. And I got to tell you, I kind of get annoyed by that language too. But, you know, it is, I saw a great meme image that kind of summed up PHP for me. And it shows a scene of Pirates of the Caribbean where the British Commodore says, "You are without a doubt the worst programming language I have ever seen." And Jack Sparrow's character with a big PHP over his face replies, "But you have heard of me." And so PHP, that 20-year-old language that has done a pretty good job of running large parts of the internet, Facebook and Yahoo included, both companies I've worked for over time. I'll tell you some great stories about Yahoo, by the way. Where was I going with that? PHP, interesting language. Let's leave it at that. HHVM is sort of Facebook's answer to getting a version of PHP that will run without being completely ridiculous. Ridiculous enough that it'll run all the rest of your code out there. Not that your code's ridiculous, but performant enough that it'll do it in a reasonable amount of time and sane enough that you're not going to want to stab your eyeballs out after a day of working on it. So that's my generous introduction to PHP and HHVM. I'm going to go over this part really quick. HHVM was originally released as a source code transformer. It would take your PHP code, turn it into C++, and then you'd have to compile it with GCC. That would take forever. Facebook's code base, which is pretty big, took on the order of, well, if we ran it on a single machine, a few days to compile. This is obviously not practical for development. We wound up throwing it over about 100 different compilation servers to get that time down. That was a bad approach. We threw that away. That was called HPHPC. What we have now is called HHVM. This is actually modeled pretty closely on how .NET does compilations of programs. Oh, we see a little more interest now because I've seen a lot of C# people out there. We actually took a bunch of people from the CLR team to develop this runtime. So we do the compilation of your script code into bytecode. That bytecode gets analyzed and optimized further and eventually becomes native code that gets run on the processor. What that means for people actually running their sites, you don't need to know how any of that works. All you need to know is take PHP out of the equation, put HHVM into the equation, point it at the same files, and it should, knock on wood, I hope this is wood, actually run and make your program act the way it's supposed to. Ta-da! Fancy transition of X. HHVM does support all of the current PHP syntax, at least up to 5.6. There are a few new things in PHP 7 that we don't support yet, but since nobody's really running 7 in production yet, God, I hope you're not yet, that's not so much concern. We are going to catch up with those few pieces in due time. I don't want to talk down PHP 7 because I think PHP 7 is a really awesome version. We've done a lot, and I say we because, again, I'm part of that project too, to make PHP 7 a better runtime. We've made it a lot faster. It's almost competitive with HHVM, or more so, depending which benchmark suites you believe, but benchmarking is like statistics. It's 80% made up. So we track ahead, making sure we run all the same code. That's great. You can do all the stuff you can do in PHP, plus a whole bunch of extra stuff that I'm going to talk about today. All that extra stuff, that falls under Hack, and I'll tell you what that is in a second. We only pass about 70% of PHP's regression tests, but the good news is that other 30% is stuff like, do we support Informix databases and MSQL? And do we give the right error message when you do something really clowny and stupid, like pass an array to echo? Well, OK, we don't match on every single one of those things, and that's why we miss about 30% of tests. What we do is we go out to GitHub and we say, what frameworks are people using? Which ones keep getting downloaded and forked and worked on? Those are the frameworks that we've been going after, and we've got the top 25 plus of them are passing 100% of their unit tests, so yay. You can see the current status of that at hhvm.com/frameworks if you're interested. If you want to just get up and running with HHVM, you want to just see what it can do, there are a number of ways to do that. The first one I'm just going to point at is the service Heroku. If you're using that for running bits or pieces of your site, I believe it was mentioned in the opening keynote this morning, you just say in your composer JSON, require HHVM. Ta-da, you're now running on HHVM. That's all you have to do for Heroku. There are some other people looking to include us in their lineup. I know Pantheon, who's a big Drupal provider, has definitely been testing us out, and they're really happy with what they're seeing so far. I'm not sure what their current status is, but if you go to their site, I bet you they'll tell you. If you're running your own stack, you've got your own servers. Facebook certainly has a few of them. You might just install it straight out of the pre-built packages that we provide in their own repository. We're trying to get into Debian, but Debian's very touchy on making sure all the licenses are correct and making sure that all the dependencies are set correctly. And well, as you can imagine, HHVM has a lot of dependencies, so sorting that out is a big project. PHP is in there because it's been in there for a very long time. So you can just add our repository, do an apt-get update install, you're ready to go, up and running, or you can compile it yourself. If you try to compile it on something like a MacBook, it's going to take many hours, so have fun with that. I've got a massive 32-core Xeon 64-bit, 3 gigahertz with 100 and some odd gigs of memory. I can do it in about half an hour, but you probably don't have the same servers at your disposal, so I'm sorry. C++ just takes a long time to compile. Getting it up and running, however you get that binary, is just like getting PHP up and running. You've got your web server with some bit of configuration that says, here's the socket I'm going to talk to my application server on, and then you've got your PHP stroke HHVM server over here with a little bit of configuration that says, here's the socket that I'm going to listen on. And they talk, they serve up pages, everybody's happy, go home, have a nice day. I did run through that fast because I don't think that's the more interesting part of it. Yeah, HHVM is a nice prototype. It goes nice and fast. It has that fancy JIT stuff, which is a great buzzword to throw out to your bosses to say, we're going to run our site twice as fast, save a bunch of money. But that only goes so far. The other half of that equation is how efficient your developers can be. How easy is it to write code without gouging your eyeballs out with forks and spoons? Well, you could drop PHP as a language. Some people do that. Or you could make PHP work better, and that's what Hack is for. Hack is actually a whole new programming language. I say new, I'm going to put that in quotes. It's actually heavily influenced and derived from PHP. You'll see that in all the syntax. Some people might want to call it PHP++, but I wouldn't, because according to PHP's string incrementing rules, PHP++ value says PHQ. I invite you to try and pronounce that yourself. I'm going to leave that to you. So, what is Hack? Well, Hack is a number of things. First off, it's type hinting gone mad. So right now in PHP 5, you can declare functions as like function foo takes an array and maybe a class of this, but that's it. You don't have the scalar type hints. Yes, they're coming in 7, but they're kind of a half measure, and I can go into that in a hallway track if you're interested in it. Hack provides all of the basic types and the complex types, bool, int, float, num, string, resource, object, array, and various combinations beyond that. Excuse me, I drank too much water. Also provides return type hints, typed properties and constants, type defs, so you can create your own specific type structures. They're called shapes. Constructor arg promotions and specialization. So beyond saying I take an array, you can actually say something like I take a numerically indexed array which has string elements or something like that. And they have these various syntaxes you see down here on the bottom, which you might recognize from Java generics or you might recognize from C++ templates. All these languages are pretty incestuous. They all get around. They have some pretty loose morals. What it also provides on top of all that massive typing and knowing all the different types of everywhere else in your system is the ability to statically analyze your code. Right now, when you write some PHP code, how do you test it? Well, you actually write tests which try to run the code in various odd and interesting ways. You throw bad data at it. You order one beer, you order 99 billion beers, you order alligator beers, you do whatever's necessary to try and QA your code. But you have to run it to make it do something. What static analysis does is it says, well, if we know that these things are these types, and we know that those things are those types, and we know that these APIs take other certain types, can we at least guarantee, at the very least, that we're passing the right type of data in and out of these things? So you're not going to be ordering alligator beers. You're going to be ordering, oh, whoops, that was a string. You shouldn't have been using it in a numeric context. And that'll tell you at compile time, and I use that word loosely. You don't actually have to compile this code, but it tells you at analysis time if you're doing something wrong or not. So what does that actually look like in practice? I've said a lot of words. I've talked very fast, and I'm doing it in this indecipherable Californian accent. What does that look like? Well, here's some example code. Again, this looks very PHP-ish. It's not that far diverged from its ancestry. We're declaring a class foo, but But we've got some extra typing in here. So our num private is an integer type. Our add function takes an integer, returns an instance of foo, et cetera, et cetera. And down at the bottom, we're actually using these objects. So f is a new foo, constructed with 1, 2, 3 as its value. We're adding in 4, 5, 6, and then we try to add banana. Now, without static analysis, we won't know that we've misused the add function by passing it a string. With static analysis, we don't have to run this code. Our analyzer is going to look at the entire program, every line, even if they're in different files, and it's going to say, hey, wait a minute. I know that f is an instance of the foo object. I know that because I just saw it set right up there. And you're trying to call the add function on it. And I know that the add function takes an integer. And you've given it a string. What is wrong with you? And it's going to tell you, foo add expected int, foo add retrieve string. Now, that might seem like a really minor, unimportant, uninteresting thing. But when you scale that up to 1,000 lines of code, 100,000 lines of code, 10 million lines of code, finding those weird little things becomes really important, especially when you want to refactor one of your classes. You've got code that works perfectly, it's great, but you think, gosh, my data access layer really needs some work, right? I want my data access layer to go to a Redis backup or something like that. So you change a few things, you modify the API slightly, but you're like, it's okay, I've looked at all the colors of this, all the colors are passing in reasonable data, it's okay, it's fine. You make that change, well, with static analysis, before you've run that code and gotten your entire database screwed up, it's telling you, hey, there's this one caller over here in some code that hasn't been touched since 1973 that you might want to look at. By the way, if you have code from 1973 that's still running, God bless you. So that's sort of the core of the initial reason for Hack. Everything that I'm going to show you beyond this point is largely some syntactic sugar that we've been piling on over and over time to make working with the language just a little tiny bit nicer. And these first few things are largely oriented around how do we make it possible for you to write less code. Because when you write boilerplate code, you don't pay as much attention to it. You're like, oh, okay, let's copy this from this other file, paste it in, change a few things, it's fine, it's work. This is code that works somewhere else, and you have duplication all over the place. It's no good. It doesn't work for anyone. This first version of boilerplate elimination is constructor argument promotion. This class is actually identical to the one you just saw, but we've changed one thing. We're not actually declaring the property in the class anymore. Instead of saying we have a private int that needs to be constructed by the constructor, we've put in construct private int num, and then no body to that. What this means is that whatever you pass into there is going to be fed into a private property on the object called num of type int, and it's automatically going to be assigned. So this constructor and this constructor, actually the same thing. Little tiny bit less boilerplate. Nothing major. It's not going to make you run out and drop Java or drop Scala or Prolog or whatever it is you're using. But it's a little thing. Next little thing, generics. Java's got these, speaking of Java. This allows you to define a class that behaves in a particular way without specializing it actually down to a type. There are a lot of times you might want to have a class that knows how to keep track of a value and add and subtract and fetch from it. Okay, maybe that's a contrived example. But in this example, we have a class that does keep track of those numbers. And we're just going to use the generic type t here. T just means, in this case, whatever you pass to the constructor, infer that out for the rest of the types where we use that placeholder t and use that type there. So again, this class is identical to this class if you're using it in an integer context. But now you can also use it as a float. So we can have $I is new foo of 1, 2, 3. It's now a foo of int. Whereas $F is a new foo of 3.14. It's a foo of float. And they both work the same general way, but for different types. Gets rid of a little less boilerplate, a little less copy pasta, a little bit more common functionality placed everywhere. Next piece, one of my favorites, not my absolute favorite, probably my third favorite, is collections. PHP's got this great construct called an array. You can throw anything in it. It's just a big bag of stuff. You can index it by number, you can index it by string, you can put objects in there, strings in there. You can throw null in there until the cows come home and nobody cares. And that's great. It's very versatile. It's done very well for a whole lot of websites. But wouldn't it be nice if you actually knew what was in that bucket before you even started looking inside? You could do that with collections. These collections come generally in about 3 shapes. That is the vector, which is a numerically indexed from 0 to n-1 of some type. So in this case, we've got a vector of int. There is the set, which is, it's essentially a non-indexed array, although obviously there are indexes in there somewhere, of some type, and each of those types have to be unique. So a set of string, you can't put the string banana in there twice. It'll only take that first banana. Map is your classic dictionary type. So you can have a particular keyish index, which means basically enter string, and then whatever type of value you want in that. And you can place collections within collections. Each of those have immutable versions, so a const version. As I believe Kelsey was showing us that immutable things are good, and you should probably not mutate them. You can do that with these im collection types. Shapes, I alluded to earlier. Shapes are basically vectors where, they're basically arrays where you have defined exactly which keys they are allowed to have. So I've got a shape here called user, and it has exactly 3 items in it that are keyed by UID, name, and age. If you try to put anything else into that shape, that's a hack error. If you try to pull something out of that, instead of just getting the default null, it's actually a hack error, and you know to fix that before you even run that code. Again, little things that can make your development just a little bit less annoying. It's taking PHP and making it act like it's almost a compiled language. So my absolute favorite feature of Hack is something called async. Now, who has used async in a way in C#, for example? There's some hands up there. Do you like it? Yeah, it's awesome, isn't it? It lets you run multiple pieces of code in like separate threads, let them do their job, and then come back together later on and join up and give you that stuff that you would have otherwise had to do in serial. Pretty much all database access in PHP right now is serial, which really sucks. Because if you need to go to one source to get your site configuration data, and then another source to get information about your current user, you're hitting one, waiting, you're hitting another, waiting, and that's taking up a whole bunch of time. These completely arbitrary made-up BS numbers I've got on the left is your typical PHP application. 15 milliseconds, 5 milliseconds, 120 milliseconds, 250 milliseconds, 50 milliseconds. These are all adding together serially. By reformatting your program flow a little bit using these asyncs and awaits, you can put a lot of these things in parallel. Maybe some of them depend on one another, and you get your overall execution time way down. I don't know if you saw the white paper Google put out a few years ago. Basically says for every 100 milliseconds you make your end users wait, they become 10% less likely to actually do something on your site. That's multiplicatively combined and not additively combined. Otherwise, they'd be gone after a second. So what does an async look like? Well, there are a few async helpers that are delivered with HHVM. First one is curl exec. This acts just like the synchronous curl exec, but this one gives you back an object immediately that says, here's my handle. Go ahead and wait on me now if you want, or wait on me with some other stuff, or come back to me later, however you want to do this. And it's going to keep track of what it needs to do to actually talk to that remote resource. In this example, I've set up 3 of those waits to go to 3 different websites. They each hand back their handle and says, all right, we're ready to actually be doing our work. And it then waits at the bottom and a join for all 3 of those to complete in parallel. That's sort of a simple contrived example. Most of your async await combinations are going to be much more complex than that. We also support memcache via a library we call mcrouter. This is designed not only to allow you to await on your memcache results, which is typically how you're going to go to memcaches asynchronously, but it also provides for integrated connection pooling. If you have multiple memcache servers out there, you can shard up your database really simply and easily. That's just kind of a side benefit, not related to async. So we can also get those by throwing them into a vector and then waiting on that vector. We can throw curls and memcaches into the same vector and wait on them despite them being different data sources. There's one for MySQL as well. MySQL will await on the connection, it'll wait on the query, and it'll wait on the database record sets that are coming back from that query. So you can have multiple stages in your MySQL await pipeline. bringing that all together, how are we going to use that in the real world? Well, I've got a contrived example here where we ask for a particular user, of our website. This get user function is going to first go to MC_router and say, all right, MC_router, do you have user : this user's ID? That's the key we're going to use for this. And MC_router either says, yes, I do, or sorry, no, I don't. And if it doesn't, we go to MySQL to select from that and eventually push that back into Memcache. We've got another one for get site data, which is going to do the same thing, but with curl as its intermediary backend of truth. And then we combine them all together in this giant map of all this information we want to get. So we're going out to 3 different source types and combining all those requests into one big bucket of work to do, and they happen all in parallel. It's hard to do a really simple example for async because it requires a switch in your thinking of how you put together programs. But it can be really, really effective at speeding up your site if you use it properly. And you guys who raise your hand, I'm sure, know that. So let's say you're really impressed and you think, wow, OK, Hack looks awesome. I love these things, especially that async. That's a really cool thing. I want to start running my site in Hack, and I'm going to switch to HHVM to do it. Oh, but I've got a whole lot of code already. Do I have to go and change all that code by myself? That sucks. So we have a nice little tool called the Hacktator. I like this tool just because of its name, Hacktator. It's fun to say. So here's some example code that we might have on our website here. These are in a couple of different files, maybe. It's completely untyped, but the first pass that the Hacktator takes going through this, it already knows a few things about your site. It says, well, within that F function, I know, excuse me, I know that the F function is either going to return an instance of foo or a null, because that's its only return statements. So it's definitely got to be one of those 2 things. So the first pass through it says, OK, this thing probably returns null or foo. That probably comes in the form of that @ symbol. Who's used PHP knows what the @ symbol means? Kill errors, yes, it's error suppression. So this script is doing its best guess, in this case a very good guess, to say this thing returns either null or foo, and that's what the question mark means. It means nullable foo. But it's not going to bet your application stability on it. So it throws that @ symbol in there. And when this thing runs over the course of maybe a week or a month on this new code, the runtime is going to actually check those live while the program's running. And it's going to say, OK, I've been returning nulls and foos, so everything's fine. If for some reason it doesn't return a null or a foo, it's going to log that to an error log that you can feed back into Hacktator, and it knows which guesses it got right. Well, let's say it's got this guess right. So we move on to the next stage, and we say, OK, well, by the way, I also knew that F probably only takes ints, because I only ever see it called with ints. So I've got an add int there. What else do we know at this point? Well, we know that G only ever returns the result from F. So the return type for G is probably also nullable foo. And what does the parameter on G take? Well, sometimes G is called with a string, sometimes it's called with a number, so we don't really know. So we're just going to skip trying to type that at all. We'll tell you that we couldn't type it, but we'll make our best guess, and this is what we're going to do. So this is where the Hacktator winds up after a few iterations running through your application. And then you let it run, as I said, for a day, a week, a month, whatever you think is appropriate for your site. And you feed the logs back into it. And if it thinks everything's OK, it's going to take those ats off, and you now have a fully typed program. Yay, you didn't have to do a lot of work for that either. Just to prove that we believe in this tool, Facebook's been using it. Facebook's code base is about, at this point, 99% fully Hack. I know you're asking why that 1%. That 1%, or in this case, in October 2013, it was more like about 4%. That 1 to 4% is basically the parts of the site we kind of don't care about. There are scripts that get run by automated processes like once a month, that sort of stuff that just happens to sit in our code tree. So the Hacktator doesn't have a chance to get a good feedback cycle on it. It doesn't have a chance to really feel like it knows what all the inputs and outputs from that are. So it doesn't make quite as many guesses. And nobody can be bothered to go to those other files just because, as I said, they're not really important to the site. We should probably delete those files, to be completely honest. But who has the time? So some other things that are in HHVM and Hack. I should be saying Hack because these are language features and not necessarily runtime features. The guys who design the language get very upset with me when I conflate the two, and so I really shouldn't. One of the things we've got are non-static defaults. So you know, parameters to functions can have defaults. If you don't pass them, that makes them optional parameters. Well, you can actually use functions. So if somebody doesn't pass a parameter to the greet function, then it will call that other function to get the default. Kind of a weird thing. You might wonder why the heck that's in there. It probably makes it more confusing. We needed that for part of our extension API, so we just sort of gave it to everyone anyway. It's my fault. Lambda syntax. This is probably my second favorite. I already told you my third and my first. Here's my second. Lambda syntax is a better way of writing closures, at least better in my opinion. Here at the top, you have some code that you could run in PHP right now, right? You've got a closure here that you pass to array map. That closure takes a single parameter, uses something from the local scope, and then returns something. And that allows you to map through the array users. Great, that is awesome stuff. But it's a bit verbose, particularly if you want it to be readable. You probably have a lot of things indented so that the code looks decent. Similarly with the filter. And never mind the fact that filter takes its arguments in the opposite order as map. That has always bothered me. Here's what that looks like with Hack. So we're still using the array map and array filter functions, but now we have these nice concise little Lambda closures. Takes one parameter, that's the UID right at the start, automatically captures the DB variable from the local scope because it knows it needs it, and then returns the right-hand side of that expression. A lot more compact. In my opinion, more readable, but that's because I've been using it for a while. Different people have different opinions on how those actually shake out in terms of readability. Now, combine those with collections. I mentioned collections are these fancy arrays that have specific typing attached to them, but also have a whole bunch of methods on them. Well, two of the most common methods on these collections are map and filter. So we can pass those lambdas directly into there. We don't have to worry about the ordering of does the array come first or second because it's an action on the object. And we can do all that work that PHP does in the top in the scope of just those couple of lines of Hack at the bottom. I love this. I don't care what you say. A silly feature of Hack, user attributes. User attributes are basically formalized dot comments. You can put any kind of information you want about the structure that comes next. Usually that structure is a function, though it could be a class as well. In this case, I've said the author of this function is S. Golemon, and it's a bit clowny because it's kind of a dumb function. It returns 42. Yay, Hitchhiker's Guide to the Galaxy. You can find this information through reflection. This is usually useful for your test frameworks. So you might say that this function has a particular dependency injection, or this function that won't mutate the database, or it can be called in a certain way to not mutate the database, something like that. I personally use it largely for the extension API. It's very useful there. It's a silly feature. Dynamic memoization. You've probably got some code right now that looks, do I have an example of this? I don't have an example of this. You've probably got some code in use right now where you do something like static some var equals null, and then if that var equals null, do some initialization that we do one time, and then store that and just return the variable. So you have like a singleton pattern for your function. Memoize will let you do that formally, so you don't have to put all that boilerplate code in. As long as you call that function with the same values, it will store that value and return it immediately on the next invocation. The example I've got here is fetching users from a database. So we've got $mark equals get user 4. The first time it hits, it's going to actually go to the database, get that user's data. But the second time that happens, when we've got $user ID equals 4, and then zuck equals get user $user ID, it's going to come back immediately because we've already asked for that user, so we've already got that user's data cache, so it already comes straight back out. And it's just a convenient formalization of that pattern. We've also got static memoization, which is a little bit more extreme. Static memoization is of the idea that if you have a static input, or a constant input to a particular function, it will always, from now till the end of the universe, give you the same output. The sort of idiomatic example of that is the MD5 function. For a given input, you should always have the same output, right? So what isFoldable will do is when that file is first loaded and it's compiling it to bytecode, it's just going to run that function immediately and then hard code that value straight in. So you skip the function call, and it's a little bit more speed efficient, allows you to be more verbose in your code. You can actually say, I want the MD5 of this string as opposed to hard coding in because you think that's going to make a big performance difference, which it won't. It's a little thing, but it's a nice thing. Null safe method calls. I haven't used this one particularly yet. If you've got a fluid interface where you might have some object that you call a method on, and you call a method on the return of that, and then you call a method on the return of that, you're probably using exceptions to deal with errors in that chain because, well, how else do you exit from that? You can't really return some sort of like proxy object. You could, but that's a weird pattern by itself. Or maybe you're doing it one step at a time and you're checking for null each time. And it's like, well, okay, if it's null, that means an error happened and we'll do something else. But if it's an actual object, then we'll call the end method on it. Null safe method calls lets you repeat that pattern, but in a more concise interface. So as you see at the bottom, question mark, arrow. If the value we're operating on is a null, we just pass that null forward. Otherwise, we actually call the method on the object. Like I said, I haven't really found a use for that yet, but some people might. XHP. So I'm going to tell you one of those stories about Yahoo right now. But first, I want you to look at this code, those of you who know PHP, and tell me what's wrong with it. XSS, yes. Very easy to tell that I'm talking about XSS since I put the example of how to take advantage of this right up in the corner. This is a pretty common pattern for people who are very new to PHP, and it's one of the things that gives it a bad reputation, right? It's really easy to shoot yourself in the foot. We're outputting user-supplied data right into our HTML. And if we do that, then the user can craft bad input that will cause another user to hit that. Maybe they hide it in an image link on their site or something like that. And the end result is that they can steal that user's cookies, impersonate them, get all their data. Bad things happen. Now, this was a very serious concern for me when I was working for Yahoo. I was working web search because, yeah, if we screw up for web search, that's probably not a big deal because what are you going to do? Force somebody to search for something? Big deal. But those cookies also reflect the email service, yahoo.com's mail.yahoo.com. And that was the thing that we were always concerned about, or at least I was always concerned about. So I was really diligent about making sure we had all the right protections against that. You had to access your query parameters to a special object, and they would always be escaped except for the one rare exception for where you had to pass that to the backend. And I heard a laugh because that rare exception is always the one that kills you. Killed us a few times. I was in the hospital in 2008, doped up on all kinds of really awesome drugs, and I woke up in the middle of the night absolutely certain that there was a XSS vulnerability in Japanese search. Now, I don't speak a word of Japanese, but I've seen the code. They have a slightly different code base than us. And so I pulled my laptop out from behind my pillow because obviously, if you're in the hospital, that's your first concern. And I punched something into search.yahoo.co.jp, and there's the alert box. I'm like, God damn it. Like, this is like 1 o'clock in the morning, and I'm really baked. So I call up my coworker, and I say, here's the problem. Go fix it. Grapefruit banana high. I'm high. And so that got fixed quickly. I don't think anyone was able to actually take advantage of it, I hope. But it's the kind of thing that can keep you up at night. Does this keep me up at night for Facebook right now? No, actually, because we have this nice little thing called XHP. This is XHTML for PHP. This is HTML as a first-class construct within the language. So on this slide, you're going to notice there's no quotes around that HTML code, right? In this case, open bracket, form, close bracket is not just 6 characters of text. It is create me a new instance of a form object. Its children are going to be what are inside this. Here's a text child ID. Here's an input child. It's semantically significant HTML within PHP, which means that when we put in these get sub ID and get sub password, the runtime knows that this is data meant for the value attribute of the input tag. And so it does all the right escaping on it. It protects the output layer from putting the wrong stuff out there. And so you don't get XSS, except for one case. There is an escape hatch for this, but I'm not going to tell you what it is. I made the mistake of telling my co-developers what the escape hatch for the query parameters were. So it gives you the opportunity to create interfaces that work a little bit better. And you can also compose elements from this. You can see I've got form actually assigned to a variable that gets dropped into a body tag. It knows that that variable is an object instance of form, so it treats it properly. You can create your own tags. So here I've created a tag called mySiteFooter. And this tag knows how to create a dim element with a couple of links in it for go to home and contact us. And it knows how to say home in either English or Spanish because it's fancy like that. And then we can drop that right into the page. We can even recreate Blink and give that back to our UI developers. Because y'all want Link, right? Link is awesome. So that's XHP. We've also got Bootstrap. Anyone familiar with Twitter's Bootstrap libraries? A few? OK. We took those Bootstrap libraries. We wrapped them up into XHP components. So you can write them straight into your XHP as well. That's mostly meant as an example exercise, just to give you an idea of how you can work with XHP and what you can do with it. But it's also, it's just nice for making pretty rounded corners. So let's say you think, great, that's awesome. Let's go hack. Let's convert all of every line of code in our code base, and let's start using hack. And then for whatever reason, you decide it's not for you. You decide maybe you don't trust Facebook because they're in league with the CIA and tinfoil hats and all that sort of thing. I totally respect that opinion. You want to go from hack back to PHP. We have a tool for that. I call it the dehackficator. There is a proper name for it. I can't remember exactly what it is. It's like hack to traditional PHP or something like that. That will take whatever hack code you've written, whether it be using collections or short lambdas, and it'll make normal PHP out of it. The one exception to that is it will not give you a PHP version of Async. That is just too low level baked into the HHVM runtime. There's no PHP equivalent of it right now. If we come up with a PHP equivalent, we'll add that in, but that's going to be some hard work the way PHP is actually designed. So bottom line to this whole thing is, in my opinion, as somebody who works on PHP and who works on HHVM, I think this has been pretty awesome because you've got, on the one hand, you've got the HHVM project building this new language that is really designed around some large engineering goals of getting that page out really fast and getting developer efficiency really high and making it possible to write really awesome programs in PHP again. And on the other hand, you've got the PHP project, who is stable and is an actual proper open source project. As much as I love what we do with HHVM, we're not quite a proper open source project because we're a little bit walled garden, but that's another story. PHP has been picking up some of these things, like those type hints. We finally got type hints in PHP. I'm so excited about that. I'm having a crazy nerd explosion about it. We've got return types over there. And speed. PHP 7 is a lot faster than any version of PHP 5 out there. If you're running on PHP 5, I urge you to at least try out PHP 7 and HHVM and take a look at the difference in performances they give you, because they're probably going to blow your socks off. And we're working together on future things. We actually are talking in open channels to come up with better stuff for PHP. So I feel like we're kind of in this PHP rebirth. And I'm going to say PHP one more time, just to go cheerleader on it. So where you can go from here, actually just this morning, or at least this morning here, I guess yesterday back home, we released the early release of the Hack and HHVM book, if you want to go and check that out. That's being done through O'Reilly. It's being written by somebody on my team. There's a link at the bottom. You can check it out. Grab me or either myself or the HipHopVM or Hackling accounts on Twitter. We're on IRC as well in #HHVM or #HHVMDev. And we've got, of course, got a couple of Facebook groups because Facebook. I know not everybody has Facebook accounts. That's OK. That's what IRC and Twitter and everything else are for. So those are out there. So thank you very much. Questions? Sorry. Oh, yeah. The question was, what IDE do we use? Well, I personally use Vim, but that's because I'm writing C++ most of the time, working on the actual guts of HHVM and Hack. Within Facebook, most of our product developers are using an editor that we call Nuclide. It's built on top of Atom. We actually announced it a couple weeks, maybe a month ago at F8. We're going to be releasing that to the public soon. It's got full Hack integration. It knows about all those weird constructs. It integrates with our debugger as well, so you can put breakpoints and watch variables and things like that. And it's going to work on Mac and Windows and all that kind of stuff. We had an editor we called FBIDE. It was something web-based, and it was built completely from the ground up, and everyone in the company was using it. And then we said, you know what, this thing sucks. We need to start over. So we decided to give up on that, and that's why we've got Nuclide coming out, which you can take a couple of ways. You can take as like, oh my God, Facebook has dropped support for something that they were planning to release. But you could also take it from the standpoint of we didn't want to give it to you because it didn't solve the problem. So hopefully that answers your question. Well, that's going back. I will mention, I do know PHP Storm is planning to release Hack support soon, just to tag onto that question.
So you're talking about an IDE separately. Do you plan to put it into some other IDEs, the likes, well, not necessarily IDE, editor, the likes of Sublime or something like that?
Yeah, so like as I actually just mentioned as the microphone was coming back there, PHP Storm is integrating with us as well. So they'll be able to call out to the hack type checker. We've got plugins for Vim and Emacs. They were actually the first two that we supported because, and this probably speaks of who's developing the product, where we think, hey, Vim and Emacs, that should support 95% of people out there, right? Apparently not. Ideally, we'd love to see it in every editor. Like most IDEs, most editors these days are pluggable. They have ways to put these things in. It's just a question of getting the know-how of how to integrate with Hack into the hands of people who are writing the modules. Writing the modules shouldn't necessarily be our job because we're going to do a bad job of it. It should probably be the responsibility of people who actually care about that editor. For an open source editor, that could be anyone. For a closed source editor, that means knocking on the door and saying, hey, when are you going to get Hack support?
The memoization, how does it handle comparison of the inputs, the arguments? So like for strings, that's relatively easy, but if it's a class or an instance?
The same sort of rules you would have triple equals on. So like, being the same, being an instance of the same class isn't enough. It's got to be actually the same instance of the same class. It's got to be, the same, the same resource instance. I guess objects are really the only ones that are kind of special in that regard. Arrays are a lot more straightforward to compare, but it's the instance ID, I guess, is my best answer to that question. Nobody's even going to ask about the elephant? Are you familiar with the PHP elephants? The blue, the greens, the reds, all those? We're working with the guys who make those elephants, and this is close to what's going to be our elephant coming out soon. And we're going to figure out how we're going to get that to people. But I'm really happy with the design. I think it's a lot more interesting and engaging than a lot of the current PHP elephant designs. So coming soon. I'm filling the silence to give people a chance to ask another question.
No more questions?
This is basically our answer to the Hack elephant, really. We almost put Hack on the side instead of HHVM because of that weird branding thing. But we decided to go for the runtime rather than the language in the name. Perhaps there will be a Hack elephant. I'm not sure what it should look like, but maybe.
Cool. Thanks, everyone. We'll have an afternoon tea break now. Thanks, Sarah.
Thank you.